get into today's stuff. Of course, Lab 1 is due right now. If you haven't already, please bring Lab 1 up and turn it in. I have homework 1 graded. Your grade should be already on Blackboard. So I will get those back to you sometime today, eventually. We'll figure it out. Just a couple other reminders and other announcements. The next homework assignment's already been posted. I just posted it right before I got to class. So this is a written homework assignment, which means you're going solo on this one, not another lab. It's due 1 week from today. It's going to be great practice for the exam, which is next week, right? So that next assignment's due a week from today on Tuesday. The exam is on Thursday. We are going to have a review session next Tuesday as well. Other stuff related to the exam, if you cannot attend the exam for whatever reason, you need to send me an email as soon as possible so that we can schedule a makeup. Please do this only if you have a very, very good reason to do so. I'm hoping to only have to offer 1 makeup time, so we'll try and coordinate all that stuff. What else is there? A question? Yes? The exam is in class on Thursday, yes, in this room. That's correct, yes. I know it's kind of cramped quarters in here, but we'll figure it out. The format is just going to be a written exam. It'll be open book, open notes, no electronic devices of any kind. So if you do want to pull something out of the textbook, you're going to need to find a way to print that out before you come to class. But no electronics. Anything else is fair game, as far as I'm concerned. Yeah? Oh, thank you. The date's right, but the day of the week is wrong. Thank you. I'll change that after class. It is due on Tuesday. Thanks. I'll fix that. What else was I going to say? I feel like there was something else about the exam that I needed to talk about, but I don't remember what it is. I'll remember it eventually. The exam is going to cover everything that we've done up until this point, including the stuff that we're going to do on Thursday. The stuff that we're doing on Thursday is fair game for the exam. The videos have already been posted. The textbook stuff is already up there, of course. Also, the chapter 2 of the textbook is due, I think, the day of the exam. So, I mean, you should be going through that stuff to review for the exam anyway, but I will be checking to see that chapter 2 is finished the day of the exam as well. Any questions about the exam stuff? Yes?
There are no calculators or electronics on the exam, like how intense will like the converting exam have like a table of hours of choose or anything like that?
I mean, you can bring whatever you want, right? I'm not going to ask you any math problems that are going to take you a half hour to compute. That's not my intention. That's a waste of time, and that's not even testing you over the material, in my opinion. I believe that you know how to do addition and multiplication, right? I trust that you know how to do that. Yes? That is entirely up to you. It doesn't matter to me how you do it. That's entirely up to you. We are going to do a review session on Tuesday where we'll go through the whole works. And I mean, if you want an outline, go look at chapters 1 and 2 from the textbook. Right? That's what we're covering on the exam. Chapters 1 and 2. Yep. Yes.
Real quick, so are we going to get like the solutions to the second homework like on Tuesday, like after
Yeah, that's a great question. Yes, I can provide the solutions to homework 2 after the due date on Tuesday and post them to the course website. I'll also, I was in the process of writing up the solutions for this. I'll try and have those posted soon as well. Although, as you're about to see, I'm going to be handing back the answer key to many of you, so that won't be entirely necessary. The grades were very good on the first assignment. Yes. Any other questions about stuff? Yes. There aren't going to be any practice exams because in the past the order that the material was covered is way mixed up. So the first exam would cover like half of this stuff and then half the stuff that you've never seen before, and the second exam would be the same way. But what I will do is keep posting lots of review questions. If you notice, I like posting review questions. That's not going to change. Tuesday is going to be a bunch of review questions as well, so that'll be, you will not have any shortage of practice. But I can't post a practice exam for practical purposes, unfortunately. Any other questions? Yes? Whatever you want, man. You can bring in a whole notebook if you want. I don't care. Open book, open notes, no electronics. Yep. Yeah, no problem. Any other questions about the exam stuff? Yes. We're going to do a bunch of them in class, so my suggestion. Potentially. I'm not sure what that's going to look like yet. I haven't made them yet, so I mean, we'll see how it goes. My intention is to do a whole bunch of stuff in class. We'll figure it out. You know, anything that I don't post in class, you're free to ask about on Piazza. I actually prefer that people, you know, ask me more specific targeted questions about the problems that we do in class instead of just saying, hey, where's the answer key? You know, it shows me that you put a little thought into the problem first instead of just wanting to know where the answers are. So I would encourage you to use Piazza for stuff like that, especially. And that goes for, you know, we don't always get to all the practice problems in class too, right? So you can go back over some of those and try them out. And if you get stuck, ask on Piazza. Myself will be happy to help you out. Any other questions? Thank you for the great questions, everybody. One other little nugget of information to dispense is that there will be another lab coming up soon as well. It's not going to be due until after the exam, so like don't worry about that in terms of, I know I'm throwing a lot of stuff at you, but I do want to get it posted relatively soon, just so that it's out there. And like I said, it's not going to be due until after the exam, so this is just kind of something that will be on your radar. Hopefully within the next week or so, I'll have the next lab posted. Okay, any other questions for me before we start doing this stuff? Fantastic. So here's how today's going to work. Today is actually going to be relatively low-key. We're going to do a few review questions up front, and then I'm going to turn you loose on a whole bunch of K-maps, and then I'm going to distribute the old homework assignments back, the graded homework assignments back, and then we'll go over the problems. There's also more than likely going to be plenty of time for you to get started on the homework assignment today as well, so that was intentional, right? I kind of want you guys to get started on that since that'll be a good review for the exam. Let's do a few review questions first. So this section was on K-maps, right? So K-maps are actually part of this algorithmic approach to simplifying logic equations. What are the steps? If I give you a logic equation, I say, simplify this using the algorithm, what are you going to do? Who can tell me the first step? What am I going to do? Yeah?
Find all the terms of
So we need to get the minterms, right? Which is, you know, first off, we need to get it into probably sum of products form, right? And then we need to figure out what the minterms are that cover that particular equation. So, you know, if we have 4 variables and I give you the term A, B, C, how many minterms cover this particular term if I have 4 variables? 2, right? I have A, B, C, D, and A, B, C, D not. So there are actually 2 minterms that cover this term, right, if I have 4 inputs. So that's step 1. Do that for all of your terms. Figure out all of the minterms that cover the existing terms within the equation. What's step 2? What's step 2? Perhaps the trickiest step. Yes? The maximal p terms, yes, and you can see I have a whole question dedicated to maximal p terms. What the heck is a maximal p term? You can describe that for me. It's a tricky concept, potentially. What is the maximal p term? Anybody want to take a stab at it? So we know it's a p term, right? It may or may not be a midterm. More likely than not, it's not going to be a midterm, right? What? Yes, in the back. I like that. I like that reference to a factor. Yes.
Basically, something is a maximal feature. It's a product term of a certain number of variables, such that all possible terms, including that term, exist.
Right. So if I give you the term BC, for example, right, and I say to you BC is a maximal p term, what does that mean in terms of, you know, the list of minterms that I see from step 1? What does that imply? Yes.
It implies that 4 things exist. It implies that
Yeah.
A, B, C, D, not A, B, C, D, and then A, B, C, not D. It implies that those all exist.
Exactly. You're exactly correct. If I give you this p term and I tell you that this is a maximal p term, that implies that all four of the minterms that contain BC exist in the list of minterms that I created in step 1, right? That is the definition of a maximal p term. If I give you a maximal p term of A, how many minterms am I looking for to declare that that's a maximal p term? Yeah. It's 8, right? Because I have 3 inputs remaining, I need all combinations of those. If I only had 2 inputs, if I only had, 3 possible inputs and I gave you A, how many minterms do I need to look for? Huh? 4. I need to look for 4. If there's only 3 here, A, B, and C, and I give you A and I say that's a maximal p term, there's only 4 combinations then in that particular case, right? So it depends on how many inputs you have, right? That's a huge factor of it, as well as how many inputs are in the maximal p term itself. That's what depends how many minterms I'm looking for. So you need to look and find all possible combinations that contain BC in order for it to be declared maximal p term. Does that make sense? Are there any questions? Because this is a critical piece of this algorithm. Okay, what's the next step then? After I find my maximal p terms, then what? Then what do I do? We're almost there. Yes? Yes, I look for minterms on my list from step 1 that only have one maximal p term included on them, right? Why do I do that? What's the point? Why do I look for that particular condition? What happens with those? What do I do with them? Yeah?
Those next features automatically are
They have to be in the simplification because there is no other p term that I can use to reference those minterms, right? There is no other way that I can pull those minterms out except for that one maximal p term. A lot of the minterms are going to be covered by multiple maximal p terms. We'll deal with those, in a little bit. But if there's only one, then I have to use it. I have no other option, right? And what happens then when I say I'm going to take a maximal p term and put that in my simplification? What does that do to my list of minterms? Yeah.
So you can take that away from the other terms,
Right, so that's kind of the last step, right? Once I declare that a maximal p term is included in my simplification, then I actually remove all minterms that contain that p term, right? They're just gone. I've covered them. So if I include BC, then I can strike all 4 of these from my list of minterms because they are all covered by this maximal p term BC. All 4 minterms are covered. So that reduces the amount of minterms that I have left. And then, as you were saying, you proceed to find maximal p terms, right? Typically, you want to find maximal p terms that are going to cover the most of the remaining minterms. So if I have a p term that covers 2 minterms versus a p term that covers 3 minterms, I'm probably going to pick the one that covers 3, give me the maximum coverage, and then keep eliminating minterms until I have none left. And then we're done. We have a simplification, right? This is hard to do on paper. I did an example in the video, which if you haven't watched it, I would highly encourage you to go watch. It took me a long time to do that. It's a pain. It's a real big pain in the butt. So in order to make life easier for us, we have these things called K-maps. So what's special about a K-map? Who can explain how a K-map works for me? We're going to be messing with them a lot today. So in my 4 input example, right, I can get us started. I'd have a grid of 16. Right? And typically I'd put A, B down the rows and C, D down the columns. What do these grid points represent? What do these represent? Yeah. Combinations of these. We have a word for this, right? Yeah. They're the minterms. They're all the different minterms, right? We're missing labels down these rows and columns. Who can help me out with those? Yeah. One, 0. And that's the same across the columns and the rows, right? Now you look at this and you're like, well, it goes from 0 to 1 to 3 to 2. That's not how we count, right? But why do we set things up this way? What's the point? What's the whole point? Yeah. We've got things grouped together, right? So the first 2 rows here represent A naught. The next 2 rows here represent B. The next 2 rows here represent A. And then the last row and the first row, right, represent B naught. So everything's grouped together with that one inconvenient thing where you have to wrap around from the bottom to the top. And it works the same with the columns too, right? Everything is grouped together. So when I put a 1 in this slot here, right, what does this represent? Yeah. A naught, B, C, D. Exactly. Exactly right. So this makes finding maximal p terms a heck of a lot easier than trying to sit down and list out all the midterms and find it on a sheet of paper. What am I going to look for when I'm looking for maximal p terms? What's my goal? Yeah. Groups of 1s. So how many 1s am I looking for exactly in a group? Yeah, go ahead. Yeah, so powers of 2, right? 1, 2, 4, or 8. If I see 1 by itself, that represents a midterm. We already covered that, right? If I see 2 side by side, what does this represent then? What maximal p term does that represent? What's constant in both of these? B, A naught, B, hang on a second. A naught, B, C. Right, exactly. A naught, B, C. Right, so it gives me a value with 3 terms in it. Right, what if I add a couple more? What's represented by this group of 4 then? B, C. We see that B is true in both of these and C is true in both of these, right? And then if I go up to 8 then, right? What do I have now? Just C by itself? And actually, if you want to, you can fill in the whole thing with 1s. This will never happen, but 16 is also a power of 2. What does this represent? True. Right? That's the easy one. You're not going to see that one on the exam, sorry. Right, but we're looking for powers of 2 clustered together in groups, right? And we don't want to make odd shapes. It's always going to be rectangular shapes, so we're not going to try and make a jigsaw puzzle out of this thing in order to find the maximal p terms. That's not going to work. We want them to be clustered together in rectangles. All right, before I turn you loose on some examples with K-maps, are there any questions about the process or K-maps in general? Okay, so here's what's going to happen next. On the next slide, I'm going to give you, I think, 3 or 4 different equations, and I ask you to simplify them using K-maps. While you guys are doing that, I'm going to pass the homeworks back. I know that's not the fastest way to distribute the homeworks, but I'm doing it because it's a good way for me to at least attempt to learn some of your names. That's why I like to do it. It probably won't take on the first try, but I'll keep trying until I get it right. This is going to take a while, right? This will take, I don't know, half hour, 45 minutes. If you get one done and you want to come put it up on the board, please let me know, because I do want to go over these at the end of class. And if you finish the K-maps and you're sitting there in your board, start on the homework. I can help answer questions on K-maps, on the homework assignments, all that fun stuff. So, yeah, this will take a while. Like I said, probably half hour at least, and then we'll go over some of these, right? Okay. Have fun. Oh yeah, the TA is not here either, by the way. Sorry about that. It's just me today. All right. Andrew, Nathan, Is that right? Oh, sorry. Benjamin Bush. No. It's the number. Just had a good question about these. Only assume the number of inputs that you can actually see in the equation. Don't assume that there are any inputs that aren't actually in the equation itself. Fernando Rojo? Fernando? Not here? Howard? Howard? Mara Evans? No, I didn't say that Peter Olson? Peter Olson? David Vittel? Here, I'll come around. Chris Yang? Chris Yang here? Zhang Zhang? I did not say that right. No, I didn't say that right. Is that you? Zachary Reefer? Ethan Vaughn? Angelica Talzu? Where? Eric Wyman? Did I say that right?
Oh, yeah. Very nice job.
Danny Weiner? Weiner? Alan Howe? Alan Howe? No. Jack Robards? Carlos Gonzalez? Michael Wang. Michael Wang here? Not here? Pierce Prasad? Is that right? Johanna Meyer? Elizabeth Bowe? I knew that one. I knew that one. I just didn't remember. Cameron, where are you, Cameron? I just saw you. Harrison Brown? Not here. Eric Zoo? William Lyons? Not here. Andy Jan? Boy Whittle?
Yeah. Can I go ahead and C++ program to do this? Oh, my program that makes it 80.
Kelly Davis?
I have a vector.
Rachel Harvey?
The other one was 60.
Daniel Gray? Margarita Gomez? And Sunny Shaw? Colin Wade?
No, no. It's response to do that. It's like you want me to do that.
Zachary Polsky. Zach Polsky. Elaine Cole. Edward Lynn. Edward Lynn. Grant Bose. Grant. Jeremy Hughes. Yeah. I had to cheat that one. John Dunnigan. Sophia Joyce. Adam Warren. Zach Erdogan. Zach. Christian Malaya. Carter Durham. Fran Wynn.
Technically, my expression.
Yeah. Oh, I'm sorry. I'm lying. Sean McManus. That's it. Did anybody not get theirs back? Not get theirs? I had one without a name on it, so. Everybody got theirs back? Fantastic.
Right.
Yeah. Yeah, exactly. Yeah. Yeah, you want to tackle the largest ones first. Yeah. And then what you did it in four, sorry, three remaining terms of this, and that. Yeah. That certainly works. When you have multiple combinations, you can't really go wrong. I mean, you just pick one, right? So, like, for example, if you were to make local recruits and decide to break this into four, would that be less than 50 or less than? That would be less than, yeah, now okay, so it's the years to essentially review the yes, with the smallest number of inputs per term. So this one was yeah. I believe that's actually this is the bottom part. I don't know. For example, I would consider it to be less simplified because we have yeah. Yeah. No, you're right. That can't specify. I'm looking for a simple meaning less number, right? Minimal amounts of stuff. So, like, you know, in fact, with that in mind, what about dropping? Like, then you're just gonna have when it gets down to like that, you're probably not going to be as picky in terms of grading and stuff. But if you obviously miss the grade, yeah, you'd have to figure out where the words got like 30 days. Yeah, yeah. That so you can't just call you like that. Something actually don't make it. Yeah, that's the point. I have to I'm sorry. They're probably equivalent to each I actually right, right. I mean, there's only these three terms, right? Oh, right. It should. And this is traditionally how it's done in the first two. But they should be equivalent. So, somewhere. I mean, the fact that this is right here, the fact that yours is like L shaped, where it's a straight when you put PC, you need someone to like you on taste. Yeah. Okay, so that's nice. Yep. And here you've got okay. Sure. Well, there's two parts to everything, right? There's a pull up and a pull down. Let me pull down. What I pull up and
Yeah, right? One time, horseback, you have to see the
yeah, I can have it's like
yeah.
Because that's the way I think that I you can basically the whole thing would be, there are, I think there are basically when you want to, because eventually it won't like, you like it would be more like really connect. Understand that the whole thing, like, they don't understand that.
Oh, I know
So
that.
that's zero, you wouldn't get
well, if the ground's on it, it's, you know, that's gonna happen, right?
right.
So these are all high, then the ground goes.
Right. But if they're not all high.
I mean, you're gonna take it. I would have to make one of them. Myself, step by step. I see it.
Exactly what I'm. You're just gonna go through every single term and it just might go through or twice. I mean, that basically is
Oh, I see what they're saying. They don't, and I actually kind of do it. On this one, you're one to hold something high and you still want to direct us so that you not
so basically what also all
like instead of connecting here, just connect it here, so that it's not pulling any type of higher than that's a little nitpicky in my opinion. Like, I don't know. Yeah. Yeah. I don't think that. That was so good. And I feel like I'd be happy to do it. No, I was thinking, oh, yeah, no problem.
I know your energy looks, but your energy is All of these are so mine is different than that because I allow it
Does anybody have the second one done? Want to come put it up on the board? Anybody have the third one done? Want to come put it up? One of you two. What about the last one? Did we get the last one? Want to come put it up on the board? Okay, I'll give you a couple minutes on that one. You want to come up? Yeah. I have to. I don't have a ton of room. Might need to wait a second.
Wait, I have a question though.
Yeah,
Like,
sure.
kind of more curious.
Okay.
So, are the KMAT or the algebraic sequence always and then are the algebraic interpretations of it? Yeah, but I kind of.
So the K-maps themselves, there's only so many different versions. The midterms are unique, meaning that if I have midterms, I know that there's no other way to write that away from the midterms themselves.
Yeah.
Since the K-maps are representing, it's the same thing. If I give you two K-maps, I have to tell right away.
Yeah, what is the problem?
Could they not like isn't like the so like for example it's strictly like you can draw something
Right.
And then just sort of
We kind of the other side. Like after you simplify it, there are often going to be many different No, let's see. No, just one. Typically, you want the absolute smallest one to possibly contain the comma, meaning the fewest number of terms and also the smallest. I prefer terms to have only one input.
oh I see that's oh okay so like
So we want to draw the bigger ones.
okay yeah but like for this one for example you the boxes are going to be the same size but you can draw like there's always you could draw like for example like cover this last string
like
instead of
this
being
square.
like 4 up and down you can like
It's not gonna.
Yeah.
No, there's like 2,000 over here.
like there's
Good,
Absolutely. No, I agree entirely, and that's that kind of speaks to the problem we talked about with some products. If I give you two equations, I can't tell right away. Yeah. This is that exact illustration, right? There are many different ways to write this. There's only one way to write it.
but the same thing that we were talking about
All the possible.
so there's only one thing that
That's correct. Yes.
okay
Yes.
okay so but I only need to
You only need to pick one equation.
okay
Draw your K-map and then pick one equation.
okay I mean like all these ones that are just like all that
Yes, but some terms will be smaller or larger. Usually we prefer smaller terms.
okay so is there a way to find like do you prefer like certain
After you pick the essential terms, it doesn't really matter. You try to pick bigger functions first. So if I can cover something with 4 instead of just 2, then I prefer the 4s, right? Other than that, there's no preference.
And then switching colors.
What do you?
oh now you're trying to
There's a little over there.
oh okay I got it
Thank you.
no problem
Slightly.
I like it. Thank you.
Yeah.
Okay, let's take a look at these. Let's see, number one is right here. Here we go. It's a little small, sorry for those of you in the back of the room. Here's our K-map. This is actually a K-map that only has 3 variables, right? So the rows represent 1 variable, and the columns then represent 2 variables in the same way as our 4x4 K-maps do, right? So we can see the terms that were filled in. It looks like AC fills in this row and then these 2 columns. AB not C will fill in this one that was actually already filled in, right? And then B not C fills in this entire column. And so the largest group that we have is groups of 2. And you can see the terms down here, AC and B not C. Or you can actually factor that C out to make it a little bit simpler. Right. Any questions about that one? That one I thought was pretty straightforward. Anybody have any issues? Yes. Like if I asked you this on the exam, this is definitely just fine, right? You don't need to take this extra step. That's okay. Perfectly fine. Any other questions? Okay, number 2. Let's take a look at number 2. So we've got these 2 midterms here, but actually, if you're doing this, you probably already noticed that you probably want to find the smallest terms and do those first, because that's going to cover a lot of area, right? So B covers out these entire 2 rows, just boom, right? And then we can take a look at these and see if there's anything else that needs to be covered. We see a B in this term already, so I already know that this is covered by that. I don't even need to look at the K-map to know that. But this one, we have a little bit of work to do. This could be either B or B naught, or A, C, D naught. So A, C, D naught is here, and it could be with B or with B naught, which gets us this one down here, right? And then we have the task of trying to choose out our terms. This guy down here is kind of isolated. There's really no way to pick him up, except for what you see drawn up here. There's really no other way to pick him up efficiently, besides what you see up here. So ACD naught has to remain in our simplified expression. There's no other way. We can't get rid of it, but this term can just go away entirely. We don't need it. It's superseded by B. Right? Does that make sense? Any questions? Cool. Let's see. Number 3. Number 3 is a bit longer. Looks like David put up some simplifications here for us to make life a little easier on us. That's nice. A, B naught, C, D. A, B naught, C, D is here, right? A naught, B, C, D. A naught, B, C, D is here. So we got these 2. Then AC and AD, he's drawn these up here for us. Take out these 2 chunks. Actually, we should have started with the smallest terms first, like I just said, right? Start with those first, take out those 2 chunks. And then the last one we have is A naught, B naught, C, D, which pulls this. Fantastic. In this particular case, this is the optimal setup, right? We could have been tempted to perhaps take this chunk of 4 right here, but that wouldn't serve us any purpose because we then would alienate these guys out here. We wouldn't be able to pull those in without this box anyway. So we might as well take this box and then this entire column. That's very nice. AC naught, CD. Much simpler, right? AC naught survives. CD is pulled in from the combination of the remaining terms. Any questions? This last one is the one I got the most questions about, so let's take a look at it and see what we've got. You can see the original expression up on the screen. So here is our grid. Again, let's start with the smallest term, A naught. That takes out these 2 rows, right? So that's nice. We've already covered half of the grid. Fantastic. I'm not going to walk through those many terms step by step. I do believe that this is the correct solution. And so, again, we're probably going to keep that A naught term to capture these 2 rows. In fact, there it is right there. The question that I got a lot is, if I have a lot of overlaps, what do I do? Which ones do I pick? There are multiple ways to do this, right? And the answer is, you want the fewest terms. You also want your terms to have the fewest inputs. So I actually like this choice of taking this column, even though it overlaps with two values that we already had. Right? I like taking this column here, C naught D, which we see down here, because it's going to give us a shorter length term than if we just took these two by itself. Right? You see that? And then to pull in these corners too, you see this is very clever. You can overlap from the top to the bottom and also left to right, which allows you to draw this odd box in all four corners, which are captured, to give us the term of, oh boy, what's that going to be? That's going to be D naught and B naught. D naught, D naught. This term right here. I like that a lot. And then finally, we have this one that's just kind of chilling by itself that we need to cover somehow. Using a 4-box term here will give us the smallest possible term that we could have used, which I'm assuming is this BD term that we haven't talked about yet. Yeah, BD. Perfect. Would I have counted it wrong if you only drew 2 boxes around these two? No, I wouldn't have counted it wrong for that. But ideally, we are looking for the smallest possible equation, which means the fewest possible terms and the fewest possible inputs per term. I believe this is the absolute smallest possible way to do it. Yes?
Well, kind of like overlap. Overlap here is good. I can better keep that 4 box for that one little one left over than just the design itself. But if you want overlap there, you gotta have just those two separate and the whole one.
Sure.
So is it better when you overlap?
Yeah.
Or does it?
So I think whether we overlap or not is not a determining factor in terms of how good our solution is. What really needs to be focused on is I want to draw the largest boxes I possibly can, right? That's what I ultimately want. I want to draw bigger boxes as opposed to smaller boxes. Bigger boxes are going to be better every single time. The reason overlap was bad here is because I have to take this column, right? There's no other way to grab these two guys besides taking this column. If I take this box here, I leave these stranded, whereas I could take this box here, and that not overlap gets me greater coverage, which means fewer terms. It would have been 3 terms as opposed to 2 terms if I had drawn this box here. Right? So in that sense, overlap is bad. That means more terms, potentially. In this case, the overlap allowed us to use the same amount of terms ultimately, but the terms themselves were smaller, fewer inputs per term. Yes. So fewer terms is going to be better. If I have fewer terms with smaller boxes, I suppose that's ultimately ideal. If it's the same number of terms, then bigger boxes win. Right? The minimum number of boxes with the largest size boxes possible. Correct. Great way of saying it. Absolutely. Are there any questions about this process? Yes. I'm okay with that. I think it's great practice. In fact, if you want some practice with the algebra part, we can go back and try and simplify these with algebra and make sure you get the same result. But ideally, the K-map, it's an algorithm, right? Which means we should arrive at the simplest version every time. That's how an algorithm works. If you do your boxes not in the best way possible, that means you're not following the algorithm. So in that case, I would be a little bit concerned, right? Like I said, I'll give you some wiggle room on the exam or something. If you would have drawn, this 2-box here instead of this 4-box, I probably would let that slide, right? I'm not going to be super nitpicky about it, but if you were to ignore this giant box across these 2 rows, I'm definitely going to take some points off for that one, right? You need to be maximizing the size of those boxes and minimizing the number of terms you have in the equation. Any other questions for me about K-maps? You are absolutely going to see one of these on the exam. That's a promise. Absolutely. We have 15 minutes left. I would encourage you to get started on your homework. I'll stick around and have office hours for the last 15 minutes. Do with that whatever you like. Otherwise, I'll see you on Thursday. Yeah, thank you.
See you Thursday.
See ya. I mean, it's just read. Translate that. Oh, this.